Hey everybody. In today's lesson, we're just going to do some examples applying more of our derivative rules with the sine and cosine function. So not a ton of crazy new content, just a few examples. Should go by pretty quick. And then just lots of practice for you guys. So let's get started. There we go. A little too far. So just a quick review. The rules we're going to be applying today, these rules we should already kind of have down from our previous units, but we're going to apply the product rule. And if you didn't have the product rule down by memory, you can just jot it down on your lesson sheet or in your notes just as a little review. So if h equals f times g, then the derivative of h, we do f prime and leave g alone, and then add f, leave f alone, and take the derivative of g. The second rule we'll be applying today, quotient rule, or that you should be expected to be apply. So if h is a quotient of two functions, f over g, then the derivative it's kind of similar to the product rule on the top. You take the derivative of f and leave g alone, minus you leave f alone, take the derivative of g. On the bottom, you square the function g. And we will apply the chain rule for sinusoidal functions too. So if h is a composite function, f compose g, then to get the derivative of h, you take the derivative of the outer function f, and you leave the inner function alone. That's important because some of you guys have a tendency to do something like this. You'd get that you take the derivative of the outer function, but then you'd also take the derivative of the inner function at the same time. So no. So you'd leave the inside and multiply by the derivative of the outer function. So let's do some examples. So with this particular video lesson, you actually guys have all the tools. You don't exactly need me, maybe just a guiding hand. So if you'd like to, once you see these problems, if you'd like to pause and try them, or if you have the lesson at home, if you want to try all the problems yourself and then just watch the video to see how you did, that'd be a great idea. But if you'd like to just kind of follow along with me, that's great too. So here we go. Let's do A. So for A, we have y equals cosine of 3x. So we know that the derivative of cosine is minus sine from yesterday. So the derivative, I'll use Leibniz notation, dy by dx. So the derivative of cosine is minus sine. But remember, the chain rule says you differentiate the outer function and you leave the inner function alone. The inner function is 3x. So we're going to leave that as minus sine. And the original did not have brackets around, but you can add brackets if you like. I might be partial to adding brackets in here. So minus sine 3x times 3. And that's it. We could clean that up a little bit. We could write that as negative 3 times the sine of 3x, or if you prefer, like negative 3 times the sine of 3x, like whatever helps you. You just need to, whatever notation you like to use, you need to resist the urge to multiply, to distribute the 3 into the 3x. You can't do that. That's the argument of a sine function. You guys never learned a rule where you could take a sine x and say that equals to the sine of a times x. There's no such rule. That's not true. So there's my wife just walking by. So that's it, negative 3 sine 3x. So let's move on to B. Maybe she'll say hi as she drops by the next time. Okay, so 2 sine of pi times x. So the derivative here. So again, we know the derivative of, there she is. The derivative of sine is cosine. And we know that the constant up front doesn't factor into the derivative. So 2, we'll leave that alone. Derivative of sine is cosine. And then again, the argument of our sine function, the inner function here is pi times x. So we're going to leave that as cosine of pi times x. Now we multiply by the derivative of the inside, which is pi. Just like the derivative of like 2x is 2 and 3x is 3, the derivative of pi times x is just pi. And so cleaning that up, we get 2 pi times the cosine of pi times x. And that's that. I suppose one last misconception that I hopefully has been beaten out of you at this point in your math careers is that this is not like cosine times pi x. That is the cosine of pi x. Pi x is the argument of cosine. That kind of comes into play a little bit with, like, say, the previous question. That misconception comes up a lot where a student might think, okay, I have sine 3x and 3, and they're all being multiplied, and then think it's all right to say even multiply in the negative and just say, like, multiply those things together. No, don't do that. So yeah, cosine and sine just by themselves mean nothing. That's the cosine of pi x. It's not cosine times pi x. Normally this is something I address in the classroom, but you guys obviously we're doing this as a video lesson. So hopefully you understand that idea. Let's try some more examples together. So here we have some functions that are trig functions, but they involve powers of trig functions. Again, you can, if you want to pause and try them yourself, that's great. Or if you just want to follow along with me, that is totally fine too. Let's do A. For some of you, you may feel more comfortable writing this as the cosine of x cubed. Those mean the same thing. And I normally would write it as the original. However, for now, some of you may find that more helpful to see how to find the derivative, because we can just see this is the power of cosine x. So you take the derivative. This is just another application of the chain rule, but this specific application we call the power of a function rule. So the outer function we differentiate, bring down the 3, leave the inside alone, take 1 off the exponent, and now we multiply by the derivative of what's inside, which is minus sine x. And that's it. We might want to clean it up a little bit. So y prime equals, so we'll have -3. And it doesn't really matter whether you like to write your sines first or your cosines first. So -3 times sine x times the cosine of x squared, or cos squared x, something like so. Let's do B. So B is very similar. It's just we have a combination of, sorry, that's just my kids are upstairs. This is going to be what it is. Lots of noise. So we just have 2 powers of x combined with subtraction. So I might again, just for for some of you guys, you may find it, you may be more comfortable writing it out this way first. If you don't need to, then that's good too. Cosine of x squared. And so this is a lot like A, just kind of 2 parts to it. So I'll use Leibniz notation here just to mix it up. So bring down the 3, multiplies by the 2, we get 6. Leave the inside alone. Take 1 off the exponent, and multiply by the derivative of the inside, which is cosine x. Now we're on to the second part. Bring down the 2, we get -8. Leave the inside alone. Take 1 off the exponent, so you can write a 1 in or not, as you please. And the derivative of cosine is minus sine x. And that's it. But as usual, we should try to clean it up a little bit. So we have 6. We have sine squared x. And we have a cosine x. And in the second term, we have, looks like +8, a sine x, and a cosine x. And that's perfectly fine. Now, as we've seen in previous units, sometimes it's helpful. Like if you're trying to sketch a curve or find like do an optimization problem, you might want to know when the derivative is 0. And we will do that ourselves. So it might be worthwhile to factor this one. Each term there has a common factor of 2. Each term also has a common factor of sine x and cos x. They have those guys there. Each part does. And what's left over from the first term, we'll have 3 and a sine x. And from the last term, we'll have 4. And that is it, just 4. The reason why that can be helpful is if, like, hypothetically, I was interested, and we're done this question. I will have actually another talking point about it. But hypothetically, if we were to be interested in setting that derivative to 0 and solving, well, now it's a lot easier. We can see, well, what makes sine x equal to 0? Like, that's, not too bad. That's things like 0, pi, 2 pi, etc. Things that make cosine 0, pi over 2, 3 pi over 2, etc. And it's going to squeeze this in here. The inner bracket's not that hard to solve either. If you set that to 0 and rearrange, you're looking for values of x that make sine x equal to, if you bring over the 4, -4 over 3. And you guys have learned skills to do that from earlier grades. Now, of course, there is no value of x that gives, because sine has to be between 1 and -1. But like, that's how you could solve that equation, without too much pain. One more little note to add. So I'm just going to erase those. Erase all that stuff. You guys learned a few identities. We used one identity yesterday in proving the derivative of sine as cosine. But there is another trig identity that is very helpful. It can make your life a lot easier. And in fact, we do make use of it in a future lesson where we do some optimization problems. And it's this identity here. I guess I'm still in green. Let's get back to blue. 2 sine x cos x, actually, you can simplify that as the sine of 2x. That's one of the double angle formulas you've learned in the past. Maybe you did not have that memorized, but if you memorize any identities, that's a super useful one. So one main one you guys learned in grade 11 was the Pythagorean identity, sine squared x plus cos squared x equals to 1. That's a really fundamental one. We use it a lot. You should have that one down as part of your math toolbox. But this one is super useful as well, that sine 2x equals 2 sine theta cos theta. That's another, that is awful rating. That is another identity that you guys should have in your toolbox as well. Can be very useful. And especially with this particular topic in the resource you guys are using, you might do a derivative and think, and check the back of the book and see that their answer is different than yours. But that just might be because they've used an identity to simplify, or they factored. So that's something that you need to keep in mind, especially this double angle formula. In any case where the book has a factor of 2 sine x cos x, they're going to write that as 2 sine x. All right, let's move forward. So let's apply the product rule. So lots of functions that model real life physical things involve a combination of sometimes polynomials, sometimes exponential functions, and trig functions. So we need to be able to work with those. So I've got 2 for us here. The first one combines a polynomial with the cosine function. So let's find its derivative. Shouldn't be too bad. We're going to use the product rule here. So take the derivative of t cubed with respect to t, that's 3t squared. Leave cosine t, plus we'll leave t cubed, and the derivative of cosine t is minus sine t. So let's clean that up. We have 3t squared times the cosine of t, and that's minus t cubed times the sine of t. And that's fine as it is. However, as usual, we're going to be setting that to 0 and solving on occasion. It might be useful to factor it. We can factor out a t squared and be left with 3 cosine t minus t sine t. So yeah, often there can be value in factoring. And again, that's something to consider. if you check the answers and yours is slightly different, maybe they factored, maybe not. Let's go on to B. Again, you can try B if you like on your own, or follow along with me. So this is another product rule where we have to combine the chain rule as well. Hopefully I left myself enough space there. So let's get started. The derivative of sine 4t is the cosine of 4t times the derivative of the inside, which is 4. And then we leave the second function. So that's the cosine squared of t. Definitely need more room than that. So I'll just bleed into a second line here. Plus, we'll leave the first function alone, sine of 4t. And the derivative of cosine squared t. So you bring down the 2. Take 1 off the exponent. That just leaves you with cosine t to the power of 1, or just cosine t. And the derivative of cosine t is negative sine t. So we did it. Let us clean that up a little bit, give myself a bit more space, and see if we can do any factoring perhaps. So we have a 4. We have cosine of 4t and cosine squared t. So as much as you would like to, you can't actually simplify that. You can't factor out COS. That doesn't make any sense. COS by itself means nothing. You have to take the argument with it as well. So cosine 4t, cosine squared t, there's nothing we can do with that to make it simpler. And the second term, we might be able to do a little simplifying. So we do have a negative. We'll have sine 4t. And if you look, we have 2 cos t sine t. So from our discussion from earlier, you could write that a bit more concisely as sine of 2t. And most resources that I would use would actually simplify to sine 2t. So again, please keep that in mind when you're doing work yourself. And just having a look, there's nothing we can do to simplify that any further. No factoring, no anything. So we've got it. So what's next for you guys? So just like you to do lots of practice. So in this section, it's just a lot of practice doing what you did yesterday, the derivatives of sine and cosine, and just applying all your different rules, product rule, quotient rule, chain rule. Possibly doing equation of a tangent line or finding the slope of a tangent line at a certain x value. So make sure you check out the posted solutions. Check out Prep Anywhere for like video solutions of certain questions. But please know that I am available during the day to respond to emails, or if you see that I'm online, then you can we can do a Google Hangouts and video conference, and I can work with you interactively. Yeah, but just know you're not like by yourself. There is help available. Making a Discord group or have some kind of video conferencing software where you can work with your friends, maybe have a set time in the day, would be a really good idea as well. But yeah, you're not in a vacuum. There are people out there that like me who'd love to help, and you don't have to do it alone. Tomorrow, we're going to spend kind of one more day playing around with trig derivatives. We're going to use our certain rules to find the derivatives of things like tan x and secant x and cosecant and cotangent. Should be fun. So have a great day. Stay busy. Stay healthy, and we'll see you guys soon.